Ionic bonding and ionic compounds. So, most of the rocks and minerals that make up Earth's crust consist of positive and negative ions held together by ionic bonding. Example, table salt, NaCl, consists of sodium and chlorine ions combined in a 1-to-1 ratio, Na plus and Cl minus, so that each positive charge is balanced by a negative charge. An ionic compound, which we know, is composed of positive and negative ions, so cations and anions, that are combined so that the numbers of positive and negative charges are equal. So most ionic compounds exist as crystalline solids. A crystal of any ionic compound is a three-dimensional network of positive and negative ions mutually attracted to each other. In contrast to a molecular compound, an ionic compound is not composed of independent neutral units that can be isolated. So the chemical formula of an ionic compound represents not molecules, but the simplest ratio of the compound's ions, and that's a formula unit. Once again, formula unit is the simplest collection of atoms from which an ionic compound's formula can be established. The representative unit of a molecular compound is a molecule. For an ionic compound, the representative element is a formula unit. Recall that a formula unit is the lowest number ratio of ions of an ionic compound. It is important not to confuse formula units with molecules. A molecule is made up of two or more atoms that act as a unit. No such discrete units exist in an ionic compound, which consists of a continuous array of ions. There is no such thing as a molecule of sodium chloride or magnesium chloride. So molecular compounds tend to have relatively lower melting and boiling points than ionic compounds. Many molecular compounds are gases or liquids at room temperature, in contrast to ionic compounds, which are formed from a metal combined with a nonmetal. Molecular compounds are composed of two or more nonmetals, which we've already went over that. Now, for example, water is a molecular compound, and sodium chloride, which is an ionic compound, are composed here. We see a collection of the water molecules in an array of sodium ions and chloride ions. We see a molecule of water and of the formula unit of sodium chloride. So we see its ions are separated, Na plus and Cl minus. And we also see its chemical formula. It's a lot of information in these last couple slides, right? So on the next page, we're going to have a chart that breaks down each characteristic of an ionic and molecular compound. Now, to close off this video, we're going to talk about polyatomic ions. And polyatomic ions are groups of atoms that are bonded covalently but carry a charge. Some examples: sulfate, phosphate, carbonate, and ammonium. We'll talk about this more in the naming and writing formula unit, which we're going to do next. So, we're going to draw Lewis structures for the following polyatomic ions. So, sulfate first off is SO4 minus 2, and ammonium is NH4 plus 1. So we'll do A first. So sulfate, group 6 valence electrons. Same with oxygen, so 6 times 4, 24. So we have 30. But now this minus 2 actually means we're going to add 2. So we're going to have 32 electrons in our structure, and we'll do this up here. So sulfur will be our central atom. Single bonded oxygens around. And since we have 32 electrons, we're going to have 3 sets of lone pairs around each oxygen. Now, the only difference when doing a Lewis structure for a polyatomic ion, we're going to put our polyatomic ion in brackets. And I'm going to erase this A here because I want to make sure we get a good bracket there. So once again, this is just A. We'll put it over here. Right, we're going to put a bracket, our Lewis structure in brackets with the charge on the outside, so minus 2. Now, NH4 plus 1, we have 5 from nitrogen, 4 from hydrogen. So 5 plus 4 is 9, but minus 1, because of the positive one, will give us 8. So I'll have nitrogen in the middle with 4 single bonds around, single bonded hydrogens around the nitrogen. Put a bracket around our ion and put a positive charge on the outside. You could just put plus or +1, whatever you want to do. And this concludes our video on ionic compounds and ionic bonds.